About 10 years ago, the National Weather Service finished assembling a national network of weather radars. These radars have vastly improved the detectability of severe thunderstorms and tornadoes. But as wonderful as it is, radar is not perfect, and there are times when severe weather is missed, or, on the flip side, a tornado warning is issued and a tornado never materializes. In many of these cases, the type and location of the radar may actually be the culprit. Here on the University of Oklahoma campus, right in the heart of Tornado Alley, researchers are hoping to demonstrate that when it comes to radar technology and tornado warnings, that smaller is indeed better. Enter CASA, the Collaborative Adaptive Sensing of the Atmosphere, a research group trying to fly under the radar with a radar of their own. True, these are smaller, less powerful radars, but don't let that fool you. They may prove to be a boon to severe weather forecasting. For example, a little-known fact is that the current weather radars don't actually detect tornadoes.
The current radars are looking up at mid-level, several miles off the surface. So what you're seeing is simply the mid-level rotation. Now that mid-level rotation may or may not lead to an actual tornado. And so it's sort of right now the technology is just not there to actually see a tornado.
Radar is constantly turning and scanning its domain, shouting out a burst of energy and waiting to hear the whisper of an echo off of a raindrop or hailstone, thereby allowing us to find and follow storms. But there is a limit to the effectiveness of this scanning. A radar beam travels essentially in a straight line, while the Earth curves away below. Consequently, cities and towns at greater distances from the radar find themselves thousands of feet or even a few miles below the beam. A storm sitting in this region won't be scanned completely. The lower portion will be missed. For the detection of tornadoes and other wind phenomenon, this is a real problem. In the Ozarks, one area which would greatly benefit from this new radar system is far out to the east of Springfield, away from existing Doppler radars. It is hoped that a network of these new radars at this range would help to fill in the gaps by sensing the all-important lower portion of the thunderstorm, where dangerous winds and tornadoes develop. Since they are small and low-powered, a natural choice for the placement of these new radars are cell phone towers, which, as we all know, have popped up everywhere. So what happens when a storm enters this network?
A thunderstorm comes into the network. All four radars, so you have four radars in the network, all four radars will sort of turn and scan towards the center of that storm and scan it. And we'll take that data, ingest all of that data into a numerical model, produce the best analysis of that thunderstorm possible, combined with satellite data and other radar data, and then we'll take that a computer-generated analysis and then tell the radars where to look for that next 30-second scan. And so it's sort of a loop between the radars, the end users, and then back to the radars again.
So what will this mean to you?
And we hope to be able to predict, say, tornadoes, minutes in advance, and therefore we could issue tornado warnings on the prediction, not necessarily even what we're detecting with the radar, but what we're predicting from the radar data. So the better the radar data, the better the forecast. The short-term forecast, particularly for the severe weather events. And so what you'll see is warnings with longer lead times but more accurate predictions.